Hi, this is a lesson for Year 10 Higher Mathematicians. It's week 10, the topic is Pythagoras' theorem, and this is lesson 30, Trigonometry, finding a side. And this first example, we're looking to find x. Now, if we're going to use trigonometry to find a side, the very first step, is to label the sides as the hypotenuse, opposite and adjacent. Now the hypotenuse is the longest side of a right angled triangle, which I'm going to label H there. The opposite is the side that's opposite the given angle, so this would be the opposite here. And the adjacent, is whatever's left over essentially. So that there must be the adjacent. Now, we're looking for the trig ratio that links together the hypotenuse, the adjacent, and the angle. We don't know the opposite, we don't want to find it, therefore that can be ignored. Now, the mnemonic we use to help us remember which trig ratio we need to use, either sine, cosine, or tangent, is SOHCAHTOA. Now, to help make that easier to use, what I've done is placed each of these trig ratios in a formula triangle. So sine is equal to opposite over hypotenuse, cosine is equal to adjacent over hypotenuse, tan is equal to opposite over adjacent. So I'm looking then for the trig ratio that uses both the adjacent and the hypotenuse. Well, here we can see this one here is not an option because it involves the opposite. This one here again involves the opposite, so it's not an option. Therefore, the one I want to use is cos of 24 is equal to the adjacent divided by the hypotenuse. So I'm going to write that down now then, having selected this one here. So cos of 24 must be equal to the adjacent, which is x, divided by 9.3. So if I've got this then, x divided by 9.3, to rearrange this equation to get x is equal to something, I must have to multiply both sides of the equation by 9.3. So 9.3 times by cos of 24. And if I type that into my calculator, that should give me an answer of 8.50 centimeters is equal to x, and that's remembered to 2 decimal places. Moving on to the next example, again, the first step is to label the sides hypotenuse, opposite and adjacent. Well, this is going to be the hypotenuse. The angle is here, therefore opposite, the side opposite that is going to be this one, and whatever's left over is the adjacent. Now, I can see that I want to find the opposite. I know what the adjacent is, and I know my angle here. The hypotenuse, I neither want to find it and I don't know it, so I can ignore that one. So I'm looking now for the trig ratio that links together the opposite and the adjacent. Well, here we've got sine is opposite of hypotenuse, therefore it can't be that one. Cosine is equal to the adjacent divided by the hypotenuse, therefore it can't be that one. The only trig ratio that uses the opposite and the adjacent is this one here, which is tan of 58 is going to be equal to x over 6.5. So let's write that down then. Tan of 58 is equal to x over 6.5. And to get the x by itself, that means I need to multiply both sides of the equations by 6.5. So 6.5 times by tan of 58 equals x. And if I type that into my calculator, I should get an answer of 10.40 centimeters equal to x. And again, that has been given to 2 decimal places. For this example here, I've tried to confuse you a little bit. Again, we have to find x. What I've done is rotated the triangle round to make it harder to identify which side is the opposite, the adjacent and the hypotenuse. Well, as it happens, the longest side for this triangle is going to be 4.8. That represents the hypotenuse. The side that's opposite the angle is this one here, and therefore whatever's left over is the adjacent. So I'm looking for the trig ratio that links together the hypotenuse, the opposite, and the angle here. I don't know what the adjacent is. I don't want to find it, so I can ignore that for the time being. So which trig ratio is it that uses both the opposite and the hypotenuse? First one I try, I can see that there's a sine uses the opposite and the hypotenuse, which is the one I am interested in. So this is the one I use. It tells that sine of 15 is going to be equal to x over 4.8. I'll write that down. Again, I want to get x by itself, so I'm going to multiply both sides by 4.8. So 4.8 times by sine of 15 gives me x. If I type that into my calculator, that should give me an answer of x is equal to 1.24 centimeters to 2 decimal places. Now this final example looks the same initially, but it will cause me a little bit of a problem when we try to solve the equation after we formed it. But let's start out in exactly the same way here, labelling the sides. This is the hypotenuse, angle, this is the side opposite it, therefore whatever's left over must be the adjacent, and I want the trig ratio that connects together then the adjacent, the hypotenuse, and this angle here. The opposite, I don't know it, I don't want to find it, therefore I can ignore it. So the trig ratio that links together the adjacent and the hypotenuse, I can just write out quickly. SOHCAHTOA using my formula triangles, and hopefully I can see that the adjacent and the hypotenuse means I'm going to use the cosine trig ratio. In other words, cos of 63 is equal to 10.4 over x. So you might notice that the equation now has been formed slightly differently. In this case, the unknown value, the x, has appeared on the denominator of the fraction on the right hand side. It's caused us a bit of a problem. We don't like unknown values to appear on the denominator. So the first thing we should be looking to do with any equation that has the unknown on the denominator is get it off the denominator by multiplying both sides by that value. So I'm going to multiply both sides by x now, which gives me x times by cos of 63 equals 10.4. Now I still, at this moment in time, don't have x equals 2 whatever, okay? But that's not a problem because I know that if I've got x times by cos of 63, if I divide both sides by cos of 63, that will get me x on its own. So if I type into my calculator then, x is equal to 10.4 divided by cos of 63. That should give me an answer of 22.91 centimetres, and that is again to 2 decimal places.